In this lesson, we're going to learn about quadratic functions as a graph and as an equation and how to identify the key features. So let's first look at the key features graphically. So here we have a quadratic function. The graph is called a parabola, and let's look at all the components. So first of all, you can see that a parabola has a line of symmetry called the axis of symmetry, which runs vertically down the middle of the parabola, dividing it into two equal parts. So we have what we call the axis of symmetry, or AOS, and this is a line and it's vertical, and so we have to label it as x equals, and it goes through -2 on the x-axis. So always write your AOS as an equation. The next thing I want to notice is the vertex. So the vertex is either the very bottom point, the minimum point, or the top point. Because our parabola turns up, the ends are pointed up, the vertex, which is a point, so we write it as an ordered pair. So in this case, it's -2, -1. The vertex is a minimum. It's the minimal, the most bottom point of our graph. Now, I do want you to notice in our vertex, the x value is the AOS. That's going to be very important when we do intervals of increase and decrease. The next thing is, let's take a look at the y-intercept, where our graph crosses the y-axis. So the y-intercept, again, is an ordered pair when x is 0. So we have 0, 3. Then let's look at the x-intercepts. I'm going to call them roots, and you can write them as ordered pairs, or you can write them with French curly brackets. So our roots, our zeros, are going to be -3, 0, and -1, 0, or from least to greatest, -3, -1. So these are the parts of our parabola when our parabola turns up. Now let's take a look at a parabola that turns down. So let's first identify the axis of symmetry, and again, it is a line, so we're going to have x equals. And so this time, our vertical line runs through +1, 2, 3. So we have x equals 3. Then we have a vertex of 3, 4. And this time, our vertex is a maximum point. That's going to be important when you do range to know if it's a maximum or minimum. The next thing, let's identify our y-intercept, where it crosses the y-axis when x is 0. So our y-intercept is at 0, -5. Our roots, or x-intercepts, is when our y is 0. So we have 1, 0, and we have 5, 0. Or we can write them with French curly brackets, 1, 5, and I always go least to greatest. Now let's take a look at some of the algebraic components that we'll get to in a minute. But the axis of symmetry, again, we just said it's a vertical line that divides our parabola into two equal parts. We're always going to write it as an equation. And here is the formula if you do not have the graph. If you only have the equation, we could find the axis of symmetry by plugging in -b/2a. And this may look familiar to you. This is the front part of the quadratic formula. So that may help you remember. The vertex is either the minimum or maximum. And again, our formula to find the vertex without a graph is we already know the x value because we established the AOS. So we said negative b over 2a. So that's your x coordinate of your vertex. Then to find the output, as always, you plug in the value of x into your equation to get the output, and that will be your vertex. The next thing we can identify without a graph are our roots. And we learned a few methods to find the roots or our solutions. Remember, you can always use the quadratic formula. And our discriminant of the quadratic formula will tell us if we have 2 real roots, 1 real root, or no real roots. So again, you can either try to factor the quadratic to find the solutions, or you could use the quadratic formula. Those are the 2 methods I generally use. To find the y-intercept without a graph, we simply would plug in 0 for x. So I would plug 0 in for x and I would get the y-intercept. And this again is without a graph. So let's talk about domain. So our domain, our graph is forever going left and right. So it would be all real numbers. Our range, we'll use the vertex to help find the range. Now our graph is solid. So our, in this case, minimum value will be included. So this ordered pair, our vertex, is -2, -1. So the range for this is going to be, the least y value is going to be the y value of your vertex. So make that connection. Your vertex tells you several things. The x value of your vertex tells you your AOS. The y value is going to help with several things, but especially your range. So in this example, our range is going to be from -1 to +infinity. And we'll look at a few more examples. In behavior with parabolas, our quadratic functions, the ends are either both going to go toward +infinity in this example, or they will both go toward -infinity because they're pointing down. So they're either both up or both down. Average rate of change, I do want to go over this. So we're going to find the average rate of change over 2 different given intervals. So let's take a look at the first one. So I am looking in the area from -5 to -3. So wherever my graph lies between this area, I want to see how steep it is from that point to this point. So when x is -5, when x is -5 for this graph, the output is 8. My other ordered pair is going to be -3. So when x is -3, y is 0. So if you did not have a graph, you would simply apply the slope formula, y2 minus y1. So y2 minus y1 over x2 minus x1. This is going to give us -8 over 2, which is -4. So let's look at it on the graph. So we have these 2 points. Again, we're looking just in this range of how steep the graph is in that area, and we have this secant line, and so we do rise over run. So it's going down 1, 2, 3, 4, 5, 6, 7, 8. And it's going to the right 1, 2. So again, we have -8/2, which is that -4 that we calculated algebraically. Now, let's take a look at a second interval. And let's practice this both algebraically and graphically. So now we're looking from -3 to 0. We're looking in this range, this area. So our first order pair, when x is -3, y is 0. And when x is 0, so x is 0, on my x-axis I'm at 0, I go up to the graph and we are at 3. So I have y2 minus y1 over x2 minus, and be careful with negatives and subtraction, so we have 3 over +3, which gives us 1. So let's look at it on the graph. So again, we're going from -3 to 0, so we're just looking in this area, and this is the secant line. So the rise is up 1, 2, 3, and to the right 1, 2, 3. So again, we get the rise over the run and simplify to the 1. That is how you find average rate of change. It is simply the slope of the secant line between the x values that will have to be given to you. Intervals of increasing and decreasing. So with a parabola, you are either you're going to have both an increase interval and a decrease. This is not like linear and exponential functions, where it's always increasing or it's always decreasing. In parabolas, you're going to have both. And you're going to use your AOS to help you write your intervals. So I always identify the AOS. So our AOS is x equals -2. So remember, you're asking yourself for intervals of increase and decrease, what x values cause the graph to increase. So let's just look at the left side of the AOS. The left side, my graph, reading from left to right, is decreasing. So my interval of decrease is going to be from -infinity all the way up until we get to x of equals -2. So from -infinity to -2, our graph is going down. So from here to here, the graph is going downhill. Then when x reaches -2, it changes the direction of the parabola and it goes up. So our interval of increase, again, you're going to use the AOS. So from here to here, our graph is going up from left to right. So we go from -2 to +infinity. So notice with intervals of increase and decrease, you're going to use your AOS value. Now, let's practice a few of these graphically. So the A value we can see in our equation written in standard form is 1. Our graph opens up. So let's identify the vertex. Our vertex is going to be -1, -9. And I'm going to go ahead and say our vertex is a minimum. The AOS, we're going to write it as an equation. And we're going to pencil it in. X equals -1. And again, you can see that the X part of your vertex is your AOS and vice versa. Make that connection. Our roots, again, I want to list least to greatest, going left to right. We have -4 and 2. The y-intercept is going to be 0, -8, and I'm always going to write my y-intercept as an ordered pair. The domain is all real numbers. Our graph is continually going left and right. The range, remember the range, you're going to use the Y part of your vertex. So my range is, again, range is what my output values are. So it goes down to -9, and it is included, unlike exponentials, and then it goes forever up, positive infinity. Okay, our interval of increase and decrease. So we have negative infinity over here, positive infinity here, and here is the turning point when x is -1. So from negative infinity to -1, my graph is decreasing. So make sure you write that in the right spot. Now, I will also say that with intervals of increase and decrease, I always use parentheses. I never use a bracket. I never include that value. Some other mathematicians may. Then from -1 to positive infinity, our graph is increasing. So we're going to say -1, our AOS, to positive infinity. Now let's do end behavior. As x approaches negative infinity, f of x approaches positive infinity. It turns up. And on the right side, as x approaches positive infinity, f of x also approaches positive infinity. So these two ends are both going in the same direction on a parabola. Okay, now let's erase a little bit of this and find our AOS. So the interval that they are giving us is from -2, so that will be one x value of one ordered pair, and +2. So when x is -2, so I'll go to -2 on the x-axis, and then I'll locate the point on the graph. Our output is -8. When x is +2, y is 0. So you could do this algebraically, y2 minus y1 over x2 minus x1, but since we have a graph, we're just going to do it graphically. Here's my nice straight secant line. And so we do the rise first. 1, 2, 3, 4, 5, 6, 7, 8. And over to the right, 1, 2, 3, 4. So we have 8 over 4, which simplifies to 2. Okay, let's move to one that turns down. Our A value is -1, so negative tells me that this turns down. If I didn't have a graph, that would tell me that. So it opens down. Our vertex is -1, +9. Our AOS is going to be the x value of our vertex, and let's pencil this in. This is going to help us with range, well, really intervals of increase and decrease. Our roots are -4 and 2. Our y-intercept is going to be 0, 8. That's when x is 0. Our domain is all real numbers. Now our range, I want to go back to vertex. The vertex is a maximum point. So when you have the vertex a maximum, this means our parabola turned down, which means our range, again, we always start with the least value that y can be and go all the way till the highest value. So this time we put -infinity, and then we put the y value of our vertex, which is 9, and it is included because it's solid here. So now let's write in x equals -1 for our AOS, because that's going to help us with these two key features here. So on the left side of our AOS, our graph is going up because we read left to right just like a book. So from -infinity up to when x is -1, this area here, my graph is increasing. And again, I'm going to use parentheses for both because I don't think a point can be both increasing and decreasing, so I'm not going to include that -1, that AOS. Then from -1 to positive infinity, on the right side of my AOS, our graph is decreasing. So the interval of decrease is from -1 to positive infinity. Our end behavior, as x approaches negative infinity on the left side of the graph, f of x approaches negative infinity. That means it's turning down. And then as x approaches positive infinity, the right side of the graph, f of x approaches negative infinity. So these two ends, this is the ends of the graph, are going to be the same in a parabola, in our quadratic. Okay, now let's do a rock right quick, the slope of our secant line. And they're always going to give you the x value of the 2 points. So our x values are going to be 0, comma something and 2, comma something. So when x is 0, so here x is 0, on the x-axis I'm at 0, then I go up and find the graph and plot that point. So we're looking from x is 0 until x is 2. So we're just looking in this area, this region, to see the average rate of change of our graph, how steep the line is. And then, so that was 8. And then when x was 2, y is 0. So there's the 2 points if you need to do it algebraically. We connect these 2 points, moving from left to right to make that secant line that's supposed to be straight. Then you're just finding the rise over the run of that secant line. So let's find the rise. 1, 2, 3, 4, 5, 6, 7, 8, and we were going down, so that's -8. And then we're moving to the right. We're always going left to right. 1, 2. So we have -8 over 2, which simplifies to -4. This is how you identify the key features graphically.